All right, we're back with our next guest here. We've got Michael Sivigny from CeTaQ. Welcome to the Apex Decode podcast set. And I just want to give you a moment to tell us a little bit about yourself and what it is that CeTaQ does.
Sure. Thanks for having me. You guys are bringing a nice level of energy to electronics, which probably has never been there. So CeTaQ Americas is a company that offers third-party measurement services for everything in the industry. And everything that we try to do is around understanding machine performance and providing solutions to customers and OEMs and those who use equipment to understand their machine performance. That's a lot of what we do.
So I know I saw a post you did that showed, I think, machine validation after some work you had done to improve the CPK, and that's super fascinating. And if I'm right, I believe you were saying you can do that regardless of vendor, right? It doesn't matter what the equipment is, who the brand, who makes it. You'll be able to help dial the processes in and get much better results. And
Correct. Everything that we're doing it's third-party independent. The measurement methodology that we're using allows us to be able to mobily go on site at factories, wherever the machines are, to measure and provide the measurement service, provide the measurement technology. And then all the different process steps, there are methods to be able to measure them. And that is the process of baselining the equipment, adjusting the equipment, and then trying to do a validation run to make sure that any adjustments that we did were successful. And then in the end result is that a machine that is performing better, in control, and meeting CM and CMK specifications at minimum from the OEM's brochure.
And the breadth of the equipment that your process can improve or measure and validate is pretty wide, right? I saw recently you made a post about a stencil laser and how you were measuring.
Interesting. That's the one you noticed.
Yeah, well, so what I'm getting at is everything from stencil lasers to pick and place to it's a big variety of equipment that you can better, essentially.
Yeah, sure.
Yeah, that's correct also. In 1996, when my colleagues in Germany designed the first system, it was to measure chip placement machine. That was it. And then as demand and interest and customer requirements started to evolve, everything started to come into play, and we've evolved with the industry to provide measurement solutions to try to help end users and OEMs understand their machines better.
That's a really helpful resource, because I know everyone kind of wonders, are the charts that the OEM shows you when you're looking at equipment, is this marketing or is this the real truth? And you guys are getting cut through that because you don't have a dog in that race. You're just going to be brutally honest about where the performance is and what the limitations are. It just will be what it is, right?
We're the foxes in that race.
Yeah.
and we're chasing them out of the hen house, essentially.
Yeah.
So the fox is watching the hen house. Yes, it is a show program for customer. It's what the OEMs want to tell the customer, and we're helping to educate everybody, OEMs as well, on proper specification, how to write it, how to understand it, and implement it, and then verify it as well.
Do you have like an example of something that you were able to tweak or the OEM was able to tweak after you guys have gone through your analysis on any machine in particular?
Yep. Printer is a good example and probably one of the most important machines in the whole process.
I agree.
And the big problem that I'm going to go on a limb and say that every OEM has with their machines is stroke-dependent offsets.
Okay.
One stroke having one set of offsets for X, Y, and theta, and the opposite stroke having its own set of X, Y, and theta offsets.
Sure.
And those offsets, stroke-dependent, affect each board that's being printed through the machine. Ideally, we want it focused on zero offset.
Okay, what would you recommend for somebody like me who doesn't yet have an SPI? How do you truly monitor and make sure that you're doing a good job with your solder paste, with the deposits and the stencil design and everything? I mean, we don't have the instant gratification and validation from having an SPI confirming what we're doing. So
But even,
how do you go about that?
Yeah, sure. Even SPI, it's measuring, and even the feedback mechanisms that some SPI have to the printer can be suspect from a metrology perspective.
Okay.
Because their machines, yes, they're set up to measure, but they don't have the measurement uncertainty budget. They don't have the cameras and the resolution and that type of technical metrology information set up to be able to make real metrology measurements and provide that back to the machine. So there's that part of it. But the other thing, to answer your question, is you have a first article pass.
Yeah.
You have to do a 2 article pass in the beginning. You have from each stroke.
One each direction.
Each direction. You need to make sure that the offsets are correct for both offsets.
Okay.
Both
And I know
stroke directions.
from a fact, like when I look at my SPI like data, because it shows you right on the screen as the jobs are running through the shop, I can tell whether my operator programmed upstroke and downstroke offsets, especially because I will see a graph going like this, and this line of every other print is in this line,
see
and
that
this line
sawtooth.
it's just right there, and then I have to say like, hey, this is clearly showing you right that the top stroke is different from the bottom stroke. The bottom stroke is more in line of where our mean is where we want to be. So let's try to get this top into this bottom,
Yep.
you know.
Yep.
But
that's the whole offset identification and
yeah.
trying to dial that into 0. But have you ever tried to dial in theta?
No.
No. I mean, it's not easy.
And I'd be
X
scared
and
to
Y
touch
you
it.
can roughly do. But when you're talking about theta, and you got to
Well,
look at all 4 corners of the
Not
board,
on my newer one, but
it's not that easy.
we actually still have like a 15-year-old semi-automatic, which is a generous term for what it really is. And you have to manually adjust the camera, the table. You have to manually adjust the table in every direction to line up the opposite corners and make sure everything's actually squared up in the apertures. So
Yep.
I'm glad we don't have to do it that way anymore.
Yeah.
That
Does not sound fun.
It makes it a lot harder to get a consistent print when you're setting up every single one. So you need some level of automation to help with that.
Correct. And then when you have a machine that's mechanically deficient, then you start adding variability to
Yeah.
your process that
Yeah.
you don't necessarily
Variance is like the
quickly-
bane of our existence, right?
quickly understand where it's coming from. And if you don't measure, you don't know.
Yeah.
It's really what it comes
Sure.
down to. It's one of our taglines, and it's so true.
Yeah.
You don't measure, you don't know. You can't understand where to go from where you are, and that's what's important.
Yeah, it's that's where my struggle is with the AOI. I use it as almost just to tell me what's wrong, right? And then tell me I just want to know what's wrong, right? But I don't currently measure how much rework I'm doing from that, right? So if I'm not looking at how much I'm reworking on that, I don't know what to fix in the process. And like, perfect example, my main quality manager went on vacation for a week, right? And then we had this other guy running, and he kept saying this connector is not getting enough pace. It's not getting enough pace, right? And it's not soldering right here, right? And then so I called Elias and I showed it to him. He goes, you need to step that guy up to a 6 mil and do a 4 mil on the everything else. And then we did that. No more rework on that connector. And I'm not lying when I say like 8 out of every 10 had to be touched up with extra solder versus that. And if you're not measuring that stuff though, it's tough to.
The question is, the guy went on vacation. Why did it get so bad when he went on vacation?
No, it was always bad. But
It was always bad. Okay.
I feel like you get used to the process and think, oh, that's just how
That's
it's
just
going
how
to
it
be,
goes.
right?
Yeah.
I've heard that before.
Yeah.
Yeah, where I remember running a job when I first started, and I was running the pick and place, and I ran something, and it ended up with all these little red arrows on it after the AOI pointing out all the errors that had popped up, and there were so many of them. And I mean, it was like, I went up to the inspectors and the rework people, and I was like, I'm truly sorry. I don't understand what happened. Like, it all looked good to me before it went through the reflow, and they're like, oh no, that's how these boards always come out. And it was one of those things where until you really think about it and recognize, well, it shouldn't be like that every time, and what do we need to change? It actually was just a matter of changing paste deposits, and the way it reflowed after that fixed everything. So You really do have to dive into those things and measure them.
Are you doing measurements before the people buy the machine, or is it usually after they have the machine and they want to see?
Yeah, can somebody bring it to you like a mechanic before they buy a car and just be like, check this out for me?
Sure. That's why our on-site service is so powerful, because we can go wherever the machine is.
Gotcha.
If it's a used machine that somebody is considering to buy, it probably makes sense to validate that machine to make sure what they're buying is ready for production. But it can be in both brand new, used, any scenario. PO contingencies work for the end user to protect them, to make sure that it meets specification before they sign the final.
So those are like CeTaQ certified. Is that like
CeTaQ certified?
There you go. Nice.
Yes.
So it's like kind of like its own registrar type of thing, right?
Yes.
I always wanted to create a new ISO just so I could make money and make people have to buy it. Yeah.
So
Congratulations to you. This is wonderful. CeTaQ certified.
No, it's great. And this has been great, honestly. Thank you for joining us. And this was, I got to say, this is probably one that producer Paul would have wished he could be on camera
100%.
because he loves this data
100%.
analysis stuff and everything you do. So, and it's interesting to all of us, too. So,
yeah, and we're going to have to
Thank you
do
for joining
a
us.
regular episode, too, because
Absolutely.
we love,
We've
we
gotta
love
have you
data.
on.
We're all data nerds.
It's all
kinda.
about data-driven
Yeah.
decisions and the future of electronics. And you just had Chris Shea on, and
Right.
she's probably touting her Ultra HDI. And if you think about printers, 90% of the printers that we measure fail their spec.
Wow.
The future of electronics, with the miniaturization and how we are going to get smaller and smaller, that stuff really has to be
There's
dialed
no
in
room
correct.
for that.
There's no
No
room.
room for error. Every aspect of the process, from stencil manufacturing, has to be correct and square.
Yeah. Well, awesome. Thank you so much for your time, Michael, and have a great show.
Thank you very much, guys.
You bet.